So, very good evening to all student members and faculty members of various departments. I welcome you all for the day 5 workshop on drone mapping and geographic information system applications. So, in today's session, we will explore how drones and the geographic information systems are enhancing the way in different industries, starting from agriculture and the construction to disaster management and smart cities, etc. Drone-based mapping is transforming several industries worldwide. Let us begin our journey into the world of spatial intelligence. So this is our workshop agenda as planned according to the sequential flow. This workshop is organized into 6 major subsections. Initially, we will start with a basic introduction to drone technology and understand the evolution and components of unmanned aerial vehicle. Next, we will study the drone mapping fundamentals, including flight planning and data acquisition. We will then explore geographic information system concepts and how drone data integrates with spatial analysis system. The fourth segment fully covers about photogrammetry and the point cloud generation. After that, we will discuss real-world applications across various sectors. Finally, we will review different software tools and complete drone mapping workflows used in industry. We shall start the introduction to drone technology. According to the existing literature, there are three major categories of drone. First one is fixed wing drone, which offers long range coverage and efficiency. Multi-rotor drones provide excellent stability and are quite ideal for mapping. Hybrid vertical takeoff and lift drones combine the advantages of both the systems. The major components include the frame, motors, flight controller, power systems, sensors such as RGB cameras, thermal cameras, multispectral sensors, and LiDAR systems. Let us now start with the drone mapping fundamentals. The drone mapping begins with a careful mission planning. Several factors influence the quality of mapping results. Flight altitude affects image resolution. Lower altitudes generally provide finer details. Image overlap is equally important, with the front overlap typically between 70 and 90% and side overlap between 60 and 80%. Ground sampling distance, or simply say GSD, which determines the size of the ground area represented by the single pixel. Proper flight speed and mission design ensure the complete and accurate data collection. Different sensors will serve different purposes. RGB cameras are used for orthomosaic generation. Multispectral sensors support crop analysis. LiDAR produces detailed 3D terrain models, and thermal cameras detect the heat variations. Now let us move on to the fundamentals of geographic information system concepts and drone data integration. Geographic information systems are the powerful tools for collecting, managing, and analyzing the spatial data. A GIS environment comprises of hardware, software, data, people, and different methods. Together, these components enable user to visualize and interpret geographic patterns and their relationships. Drone-generated data must be referenced to coordinate system, such as Universal Global Reference Coordinate System, say WGS84. The ground control points, commonly known as GCPs, improve the geospatial accuracy and ensure reliable results. GIS datasets are classified into two types, vector and raster patterns. So drone orthomosaics, digital elevation models, and terrain models are examples of raster data, while points, lines, and polygons represents the vector data. Now let us discuss the information on photogrammetry and 3D point cloud generation in drone mapping. Photogrammetry is the science of extracting measurements and three-dimensional information from photographs. The workflow begins with image capture, followed by image alignment and dense point cloud generation. These point clouds are then converted into texture 3D meshes, digital elevation models, and orthomosaics. An orthomosaic is a geometrically corrected aerial image with a uniform scale. Digital surface models include trees and buildings, while digital terrain models represents bare earth surfaces. These outputs provide highly accurate and actionable information for engineering, planning, and environmental applications. Let us now see some of the real-world drone application in geographic information system. Drone mapping and GIS technologies have several applications across numerous industries. In precision agriculture, drone helps monitor the crop health, optimize irrigation, and improve the yield cultivation through NTVA analysis. There's nothing but normalized difference vegetation index. In construction, drones support site monitoring, volume calculation, and the build information modeling integration. For disaster management, drones provide rapid flood mapping, damage assessment, and search and rescue support. Urban planners use drone data for cadastral surveys, infrastructure planning, and smart city development. Mining companies employ drones for stockpile measurements and safety monitoring, while environmental agencies use them to study forests, wetlands, and wildlife habitats. So these are some of the real world the drone application under geographic information system. And here are some of the software tools used in GIS application. The complete drone mapping workflow involves mission planning, photogrammetric processing, and GIS analysis. Popular flight planning tools include DJI Pilot, Fix 4D Capture, Mission Planner, and Quantum Ground Control. For photogrammetry, industry standard softwares includes Agisoft Metashape, Pix4D Mapper, and DJI Terra and Open Drone Map. GIS analysis is commonly performed using Quantum GIS, Arc GIS Pro, Google Earth Engine, and Grass GIS. These tools enable better visualization, fine quality image measurement, classification, object classification, and advanced spatial analysis. Now let us discuss about accuracy, ground control point, and best practices involved in GIS application. Accuracy is one of the most important critical factor in drone mapping projects. Ground control points are the surveyed markers placed throughout the project area to improve the georeferencing accuracy. Typically 5 to 8 ground control points are recommended for larger sites. Modern RTK enabled drone. It is nothing but an industry standard drone which is used for surveying, even for rescuing operation. So this type of drones can achieve centimeter level accuracy even with the minimal ground control points. Best practices include checking airspace permissions, calibrating the sensors before flight, maintain visual line of sight during operations, and validating the results using independent checkpoints after processing. Following these procedures ensures reliable and professional mapping outputs. So here we are going to see some general information on practical information regarding agricultural drone mapping, a case study. Let us examine a practical case study involving a 50-hectare paddy field near Pondicherry. The project used a DJI Matrix 300 RTK drone equipped with a multispectral camera to capture the crop health information across multiple growth stages. Image was being processed using PIX 4D mapper and NDVI maps were generated. GIS analysis in QGIS enabled classification of crop zones and identification of nutrient deficiencies. As a result, the fertilizer usage was reduced by 23%, crop yield increased by 18 percentage, and survey time was reduced from 3 days to 6 hours. So these are some of the key results and outcome from this case study so that we can maintain a 2 centimeter mapping accuracy. So this case study tells about the quality of object detection, image recognition, classification of image according to the sensors that has been incorporated into the drone system, and the time lead time reduction in gathering the data. So everything has been uh, done with this 2 centimeter mapping level accuracy. So this was the final key results and outcomes from this practical illustration of case study. What are the different future trends in drone GIS technologies? The future of drone GIS technology is driven by innovation and digital transformation. Artificial intelligence and machine learning are enabling automated future extraction, object recognition, and predictive analysis. Digital twins are creating virtual representation of smart cities and infrastructure for real-time monitoring and decision making. Swarm drone technologies allows multiple drones to work collaboratively over large areas. Edge computing and 5G networks facilitate real-time processing and data transmission. Convergence of building information modeling and the GIS will further enhance the construction and infrastructure management, while hyperspectral imaging will unlock advanced environmental and agricultural insights. What are the various key takeaways and the final closing remarks? To summarize the above information, so it is noted that drones have transformed the spatial data collection by making it faster, safer, and more cost effective. When integrated with the GIS, drone data becomes a powerful source of spatial intelligence, supporting informed decision making across industries. Photogrammetry enables the creation of orthomosaics, digital elevation models, and 3D point clouds that provide valuable insights for professionals. As technology continues to evolve, opportunities in drone mapping and GIS will expand significantly. So, finally, I thank all the members for participating in today's workshop. I appreciate your kind attention and interest in knowing a lot of new technologies in mechanical as well as aeronautical engineering. So thank you once again. We will meet in the next subsequent day, day 6 workshop. Topic, theme, and agenda of the program will be announced later. Thank you.